Hello everyone, welcome to my tutorial. Today we are going to discuss graph terminology. So the first one is adjacent nodes or neighbors. It's a self-explanatory term. Uh, Adjacent nodes are the nodes which are connected by an edge. For example, in this graph we can see that A and B are connected by E1. Therefore, A and B are adjacent nodes or neighbors of each other. Similarly, B and C are also connected by E2. Therefore, B and C are adjacent nodes or neighbors of each other. Second one is multiple edges. Multiple edges are the two edges which connects the same pair of nodes. For example, in this graph, C and D are connected by an edge E5 and E6 also connects the same pair of nodes C and D. Therefore, E5 and E6 are multiple edges. Loop can be defined as an edge to itself. For example, we can see that there is an edge E4 whose starting point is B and whose ending point is also B. So therefore E4 is an edge to itself and E4 is a loop here. So multigraph can be defined as a graph which consists of multiple edges or loop. The graph shown here is an example of multigraph and it consists of multiple edges E5 and E6 and it also contains a loop E4. So now we will discuss the degree of a node. Degree of a node can be defined as the total number of edges containing that node. Okay. So for the directed graph, there are two types of degree, indegree and outdegree. Indegree of a node can be defined as the number of edges that terminate at that node. Okay. For example, in the graph shown at right, we can see that there is a node C whose indegree is 2 because there are two nodes terminating at C. Node from A to C and edge from A to C and edge from B to C. These are the two edges terminating at C. Therefore, we can say that the indegree of C is 2. Outdegree is quite the opposite of indegree. Outdegree can be defined as the number of edges that originate from that node. In the same graph, we can see that there is a node D whose outdegree is 2 because there are two edges originating from node D. Edge number 1 is D to A and edge number 2 is D to B. So the outdegree of node D is 2. For a directed graph, degree of a node is the sum of indegree and outdegree. Okay. As we can see in the example, in the graph shown at the right, the degree of node A is 3, which is equal to 2 plus 1. 2 is the outdegree of node A and 1 is the indegree of node A because there are two edges originating from node A and there is one edge terminating at node A. Therefore, the degree of node A is 3, which is the sum of its indegree and outdegree. But for an undirected graph, there is no concept of direction associated with edge. Therefore, for an undirected graph, degree of a node is equal to the indegree, which is also equal to the outdegree. The indegree, outdegree, and degree, these are all the same in for undirected graph. As we can see in the example, in the graph shown at the left, the degree of node B is 1, 2, 3, 4 because there are 4 nodes containing the node B. Now we'll discuss path. Path is also a self-explanatory term. Path is basically a sequence of nodes in which two consecutive nodes are adjacent nodes. For example, in the graph, we can see that there is a path from A to C which consists of two edges. Edge number 1, A to B, and edge number 2 is B to C. So this can be considered as path from A to C. So now the closed path. Closed path is a path from the node in which starting node and the ending node is same. For example, if we consider the path A to B, B to D, and D to A. In this, the source node is A and the destination node is also A. So this is a closed path. Simple path is a path in which all nodes are distinct, but ending node and starting node can be the same. So simple path contains all the paths in a graph plus all the closed path in the graph. Okay. Now cycle. Cycle is quite similar to closed path. Uh, uh, as we can see, in the graph shown here, there are three cycles A, B, C, A, B, D, A. This is the first cycle. And second cycle is A, B, C, E, D, A. This is second cycle. And third cycle can be B, C, E, D, B. So there are three cycles in the graph shown here. So now we'll discuss the various types of vertices. First one is isolated vertex. Isolated vertex is a vertex with degree 0. As we can see in the graph shown below, G is the isolated vertex because it has a degree 0, because there is no edge containing the node G. There is not a single edge terminating at G and not a single edge originating from G. Therefore, the degree of node G is 0 and G is an isolated vertex. Second one is pendant vertex. A pendant vertex is a vertex with degree 1. It is also known as the leaf vertex. So in the graph shown below, I is the pendant vertex because the degree of node I is 1, because there is a single edge originating from node I. So therefore the degree of node I is 1 and it's an pendant vertex. The third one is cut vertex. A cut vertex which when deleted would disconnect the remaining graph. Okay. So as we can see in the graph shown below, D is the cut vertex because if we delete D from the graph, it will disconnect the graph. ABC itself will become a graph and EHFI will itself become a graph. So therefore D is the connecting the graphs and D is the cut vertex. Now source. A source is a node if it has a positive out degree but zero in degree. It means that a node is a source node if there are edges originating from that node but there is not a single edge terminating at that node. In the example, we can see that B is the source node because there are two edges originating from B but there is not a single edge terminating at B. Therefore, B is the source node. Similarly, sink, a node U is known as sink if it has a positive in degree but zero out degree. It means that a node is said to be sink if it has edges terminating at that node but it doesn't have a single edge originating from that node. So in the example, we can see that F is the sink because it has three edges terminating at F, but there is not a single node originating from F. Therefore, F is the sink. Now we'll discuss the graphs. A regular graph. A regular graph is a graph where each vertex has same number of neighbors. That is, every node has same degree. Okay, in the example shown here, we can see that every node has two edges attached to it. Therefore, the degree of every node is 2. So it's an example of regular graph. It's an example of two regular graph because every node has a degree of 2. Second one is connected graph. A graph is said to be connected if for any two vertices u, v, there is a path from u to v. Okay, we can say that a graph is connected if there is a path from every vertex to every vertex. Okay, if there is a single node which is isolated, then we can't say that the graph is connected because there is no path to the isolated node. So for a graph to be connected, there should be a path from every node to every node. Now the complete graph. A graph is said to be complete if all of its nodes are fully connected. It means that there should be a direct edge from every node to every other node. Okay. Now there is an important point to note here. A complete graph has n into n minus 1 by 2 edges having n nodes. Okay, we can derive this formula. Imagine we are having n nodes, n number of nodes, and we have to establish a direct connection between every pair of nodes. So how many connections there would be? So the answer would be NC2, which is equal to the n into n minus 1 by 2. So for connecting every node to every single node, uh, we need n into n minus 1, n minus 1 by 2 edges. Okay. Now, labeled or weighted graph. A graph is said to be labeled if every edge in the graph is assigned some data. For example, in the graph shown here, every edge here has a data assigned to it, which is known as the weight of the edge. Okay, also it is also called as the cost of the edge. Now we'll discuss some more terms. First one is reachability. It is also the self-explanatory. A node V is said to be reachable from node U if there exists a path from node U to node V. Second is a strongly connected directed graph. A digraph is said to be strongly connected if and only if there exists a path between every pair of nodes in G. It means that if in a directed graph, if there is a path exists from node U to node V, then there must be a path from node V to node U for that graph to be strongly connected directed graph. Okay. Now, unilaterally connected graph. A digraph is said to be unilaterally connected if there exists a path between any pair of nodes UV in G such that there is a path from U to V or a path from V to U, but not both. Okay. Uh, Suppose we have given an example of connected graph and we can find a path from U to V in that graph. So for that graph to be unilaterally connected, there should not be a path from V to U because there already exists a path from U to V. So if there is a path from U to V, there must not be a path from V to U. And if there is a path from V to U, there must not be a path from U to V. In that case, we can say that the graph is unilaterally connected graph. The last one is simple directed graph. A directed graph G is said to be directed graph if and only if it has no parallel edges. However, a simple directed graph may contain cycles with an exception that it can't have more than one loop at a time. Okay. A simple directed graph can't have parallel edges. Okay, if a graph contains parallel edges, we can say that it's a simple directed graph. For a graph to be simple directed graph, it should not have parallel edges, but it may contain one loop. It means it may contain an edge to itself, but not more than one. Okay, so we have discussed all the terminology related to graphs. That's all for today. Thank you for watching this tutorial. Stay tuned for more updates.